Have you ever wondered what's in Crystal Light or other instant drink mixes? Or if you could make them at home? Well, keep watching and you'll find out. Hello, and welcome to Neutral Breakdown. Today, we're breaking down Crystal Light. So these are drink mixes. This flavor is lemon iced tea. So if we actually take a look at one here, we can see that it's in this mylar wrapping. That's to keep it airtight, keep it watertight. There's a powder in here, so definitely want to make sure that stays dry. And if we open one up and have a look inside, we'll see that it pours as kind of a grayish brown powder. I have a bit of water here, so if we pour that in, we'll see that of course it dissolves very readily. So let's take a look at the nutritional information here. And right off the bat, there's something interesting. We see here that the serving size is a half of a packet. That means that each packet contains 2 servings. If we flip over to the other side, we see that its intended usage is to be dissolved into a 16-ounce bottle of water. And what really is interesting here is that if you look at another industry that's related to this, the soft drink or the soda industry, if the product can reasonably be assumed that a consumer will sit down and actually eat or drink the entire container in one sitting, that has to be labeled as containing 1 serving. So if you look at the bottles now, even a 20 ounce, it is say serving size 1 bottle. So I find it interesting that they're able to have 2 servings per packet, even though one single packet is supposed to be dissolved into a 16-ounce bottle or a glass of water. And the reason for that is right here is this calorie content. So 5 calories, and this is per serving, not per packet. So 5 calories per serving means that there are 10 calories total in the packet, and they're very proud of that 5 number. You know, in your mind, 5 is, it's half as small as 10. So we see this here on the front of the package, and we flip over to the back. Have a glass, Crystal Light drink mix. Lets you add flavor to your life with just 5 calories per serving. So it seems a little devious to me that they market that so heavily, but actually you're getting double this. You're getting 10 calories. And more than just that, these values here, you say zero total fat, 0 sodium, 0 carbohydrates, 0 sugars, and 0 protein. Well, these are actually non-zero values. And the reason they're 0 on here is because they're close enough to 0 that it makes more sense to round them down than it does to round them up. But when we take a look at the list of ingredients, some of these ingredients do actually contain a fair amount, per volume of calories and carbohydrates. So my hunch is that if this were 1 serving per packet, that some of these numbers would be high enough that they would actually have to list them as real quantities, as 1 gram. There's a big psychological difference between 1 and 0. So that is my thinking behind this serving size. Obviously, we can't prove it because we don't know the real quantities of these ingredients, so we can't truly calculate that, but I'll just call that a strong hunch. All right, so let's actually take a look at the list of ingredients here. Now, it's important to note that these ingredients, and in fact, any ingredients on any FDA-certified food product, they're listed in order of descending predominance. So what that means is, let's take this first ingredient, citric acid. It's the most predominant ingredient in this product. That doesn't mean that it's mostly citric acid. It just means of all the ingredients, citric acid is there in the highest quantities, and then second highest, third, so on and so forth. So let's dive in. First up, we have citric acid. So this is an acid. That means that it has a low pH, and it's going to taste sour. Anything with a low pH tastes sour to us, while on the other hand, anything with a high pH is going to taste bitter. Think of like a bar of soap. Now, citric acid is a natural compound. It's found naturally in citrus fruits. You can see here, they feature that prominently with lemons. You can also find it in limes, oranges, grapefruits, anything like that. And that's actually originally how it was produced. It was produced from Spanish lemons. That's not how it's done now, though. And the reason for that is that during World War I, the Spanish lemon supply was interrupted. So industry had to find another way to produce it. And the way they did that, and what they do now, I'm assuming because it's cheaper, is that they have a mold, a specific strain of mold that eats starches, it eats carbohydrates, and it produces citric acid, which, granted, sounds really gross, but it's not really anything to worry about because although it is produced by a mold, it's refined and the citric acid is extracted, and you end up with just pure citric acid. You don't end up with any kind of mold or bacteria or anything weird like that. So what they're using the citric acid for here in this instance is it's going to give it a bit of a sour flavor, and it's also going to kind of give it a citrusy flavor. That's what actually makes the lemon in this lemon iced tea is the citric acid. So next up we have maltodextrin. Now this is it's a carbohydrate known as a polysaccharide. And it is produced from starch as well. In the U.S., it's produced from cornstarch, while in the EU, it's produced from wheat. And it can be used as a sweetener. It varies anywhere from like not really sweet at all to kind of a mild to strong sweetness. And I thought that's what it was being used for here because it's the second ingredient. So that tells us that it's the second most by volume of all the ingredients. But after trying to make this myself, I don't think that's what they're doing with it here. Because the big difference between what I'm going to show you later in the video of a replacement DIY for this drink mix and the actual drink mix is kind of the texture of it. If you're used to drinking a syrupy beverage and you know it has that certain feel, and you make something that doesn't have that, it's not going to taste as sweet to you. So I think that's what they're using it here for, is just kind of a texture, kind of a thickening agent, and not so much of a sweetener. Now it may add some sweetness to it, but I don't think that's its primary function here. All right, so next up we have corn syrup solids. We have a little notation here that tells us it adds a trivial amount of sugar. The reason why it does that is that this corn syrup solids is basically the same thing as corn syrup. The only difference is that this doesn't have as much water in it. They dry it out. So corn syrup solids contain 10% or less by weight of water. Corn syrup contains 10% or more by weight of water. That's the only real difference. It's produced from corn starch. They take an enzyme, they add it to the corn starch, and it produces what's called maltose. And maltose is just two glucose molecules that are bound together. So that when they enter into your body breaks them down. It breaks down that maltose into the two separate glucose molecules, which means that this corn syrup is basically 100% glucose. So these corn syrup solids, what they're doing in this product is they are providing a sweet flavor. There are a few artificial sweeteners as well on down the list that are doing the same thing, but in addition to those, that's what gives this the sweet taste. Next up, we have instant tea. Now, this is probably my favorite ingredient in this entire product. It's really neat how it's produced. It's a cup of tea that's been dried and turned into powder. They take tea leaves, they grind them up, and make a cup of tea out of them, they dehydrate it until you're just left with the volatile organic molecules, the flavor components, the aromatics, the things that make tea taste and smell like it does. So really simple in terms of ingredients and what it adds to the product. I mean, it gives you a tea flavor. Now, how they actually turn it into a powder is really interesting, and I would like to make a separate video about that. So if you're interested, maybe leave a comment below and let me know, see if we can get that into the queue. All right, so next up we have aspartame. Now, there is a lot of controversy surrounding this ingredient. I'm going to try not to really get into any of that. I'm just going to give you the facts. I'll let you draw your own conclusions. But it is an artificial sweetener, meaning that it doesn't exist in nature. It's man-made. In fact, it was discovered by James Schattler in 1965. He was trying to create an anti-ulcer drug, and he was in his lab and he happened to lick his finger and noticed that it was sweet. So we got to investigating, and this is a side product of the production of his anti-ulcer drug. So after that was discovered, this went into production and became ubiquitous. And in fact, I don't even think his anti-ulcer drug ever made it to market, but this, sure enough, did. You can find it in most things that are diet sodas, diet lemonades, diet drinks, any kind of diet thing that needs to be sweet is going to have this aspartame in it. Now, the one place you won't find it is any kind of baked goods, anything that has to be cooked or baked or exposed to heat. The reason for that is this breaks down at high temperatures. So you're not going to get the same consistency, you're not going to get the same texture that you would if you just replace this for sugar. Now, and a lot of people think that aspartame is 0 calorie, 0 carb, artificial sweetener, something like sucralose. That's not really true. It does contain, per tablespoon, 38 calories and 9.4 grams of carbs. Now, if we have something to compare that to, let's say regular table sugar per tablespoon contains 46 calories and 12 grams of carbs. So really, it's not that much different in terms of carb and calorie content. But the reason it's used in diet products is that it's so much sweeter than sugar. In fact, it's about 200 times as sweet as sugar, which means you can use a whole lot less of it. Just a little bit of aspartame will give you the same apparent sweetness that a lot of sugar would. So that's why you can use just a tiny bit of it, and it doesn't really affect your nutritional contents here because it is so incredibly sweet. Now, there is something to note here that you see we have this notation for phenylketonurics that it contains phenylalanine. And what that means is that this aspartame, when you ingest it and your body metabolizes it, it breaks it down into three things. It breaks it down into aspartic acid, phenylalanine, and methanol. Now, a lot of people think that the methanol is really the bad part here, but not so much. Methanol is a normal part of your daily diet. It's included in a lot of fruits. Some alcohols actually contain a very, very small amount of methanol, and your body has ways to deal with that. On the other hand, this phenylalanine, some people have issues breaking this down. Their body can't really break down or digest this phenylalanine, meaning that it can build up in their systems and cause a lot of adverse side effects. Now, what it's doing here is, of course, a sweetener. In addition to the corn syrup solids, this aspartame, and we have one other one we haven't covered yet, is what actually makes this product sweet. Maybe the maltodextrin too, but like I said earlier, I think that's really more for texture than anything. Now we come to the contains less than 2% of. And the thing to note here is that everything after that statement is 2% or less by weight of the overall product, but they're not in order like the ingredients up here are. They can be in any order the manufacturer wants them to be. So we see BHA here is last and magnesium oxide is first. That doesn't mean that there's more magnesium oxide than there is BHA. It can very much be the other way around. It's whatever order they want to put them in, as long as each ingredient is no more than 2% by weight of the total product. All right, now this natural flavor, that is really more of a category than an actual ingredient, because there could be a lot of things under this natural flavor label. The only thing that's a requirement for it to be labeled as a flavor, either natural or artificial, is that it only contributes flavor to the product. Like, it doesn't have any substantive value. Now, the natural part of it just means that it's derived from a natural product. It's derived from a plant or an animal source, as opposed to a artificial flavoring, which is chemically produced, man-made. It doesn't start from a natural source. All right, next up, we're looking at magnesium oxide. Now, this is a mineral. You'll find it as a white powder, or you can see it in a suspension in a liquid. It's going to be kind of a milky white color. It is naturally occurring, and its primary use is actually in heavy industry. It's used as a refractory material because it doesn't break down at high temperatures, meaning you can get it really, really hot, and it's not going to melt or oxidize or do anything like that. It's going to stay stable. So it's used as a refractory material. What that means is anywhere that there's going to be high heat that needs to be reflected back or stopped from reflecting out, they're going to use this magnesium oxide. So think of things like crucibles and steel forges, anything like that. Now, its other use is actually as a laxative. You can find it in the drugstore under the name milk of magnesia, and you can take it to relieve constipation. Now, that's not what it's doing here. Obviously, it's not marketed anywhere on here. They don't want people to take this and all of a sudden, have to go to the bathroom. So what it's doing here is they're using it as a desiccant, basically just a drying agent. So when they're packaging this, if there's any kind of moisture or water in the environment where they're packaging it, this magnesium oxide is going to absorb it. It's going to dry out the powder so that it doesn't clump up and look real gross when you try to pour it out. So, and we can show that with a bit of quick tabletop math here. So we know that the magnesium oxide is 2% or less of the total weight of a serving size being a gram. So we're going to take a gram. We want to get 2% of that, which of course is going to give us 0.02 grams, or 20 milligrams. And since we know that a serving size is a half a packet, and really most people are going to consume the full packet in a sitting, let's go ahead and be realistic and multiply that by 2. And that's going to give us 40 milligrams. So this is the total, the maximum value of magnesium oxide you could have per an entire packet. And that's even maximum. See, it's 2% or less, so it can be even less than this, but this is the maximum value. Now, to compare this, it's 1,000 milligrams of magnesium oxide if you want to use it as a laxative. That means that, of course, it's not what it's doing here. It's a drying agent. It's just to keep it dry, not any kind of laxative effect. In fact, if you wanted to use this as a laxative, and I don't recommend that, I'm not sure why you would, but you would need to consume 25 packets to get anywhere near 1,000 milligram dosage, which is what you would want if you were using it as a laxative. So not what it's doing here, but interesting to note that the same ingredient or the same compound can have multiple uses. So here it's a drying agent, but also used as a laxative. All right, so next up here we have acesulfame potassium. Now this is another artificial sweetener, so it's going to be used in conjunction with possibly the maltodextrin, definitely the corn syrup solids, and the aspartame to sweeten this product. Being an artificial sweetener means that it is man-made, and unlike the corn syrup solids and the aspartame, this is actually 0 calories, 0 carbs, nothing. But it still does taste sweet, and not only does it taste sweet, just like the aspartame, it is about 200 times as sweet as regular sugar. Typically, you won't see this used alone. It's paired with aspartame a lot. Apparently, when it's paired with aspartame, that you get closer to an actual sugar taste. Because aspartame doesn't really taste like sugar on its own. This acesulfame potassium certainly doesn't taste like sugar on its own. Apparently, it's really bitter. But when you combine the two, you get closer to what you would expect from regular table sugar. And this can actually, as opposed to aspartame, this can actually be helpful for people with diabetes just because it doesn't break down to a glucose compound. One other thing to note is that also, unlike aspartame, this is actually stable with heat. So if you are using a diet or a sugar-free product that needs to be cooked or baked, you'll see this acesulfame potassium in there because it's not going to break down and combine with other things when you heat it up, unlike the aspartame will. Next, we're taking a look at the food dyes used in this. We have red 40, yellow 5, and blue 1. Now, I said there's a lot of controversy surrounding aspartame. Well, same thing with the food dyes. They don't add anything to the product other than the color. That's what's giving you the color here. And, they don't add any kind of nutritional value. They don't add any kind of flavor. All they do is add the color. And sometimes that can kind of trick your brain into having a certain flavor reaction, a certain, taste sensation when you eat the product. But for the vast majority of uses, it's just for advertising. It's just to make it look a certain way. So let's start off with this red 40. So it's an azo dye. And like most azo dyes, it's derived from petroleum. It's a petroleum byproduct. In this case, it's derived directly from naphthalene, which some of you may know is actually mothballs. So that like really bad mothball smell that you probably know from your grandmother's house, that's actually what this red 40 is made from. Now, that's not saying that red 40 is naphthalene. Totally different compound, totally different effects, but it's interesting to note that, in fact, that is where this comes from. Now, the red 40 food dye itself is pretty controversial. The FDA actually published a study. They found a possible link between this food dye and hyperactivity in children. They didn't say anything about adults, but they said there's a possible link in children. However, the FDA does approve it for use in cosmetics, drugs, and food as a dye. This is definitely the most popular food dye out of all of them produced. Annually, it's produced in quantities greater than 2.3 million kilograms. And it's not really heavily regulated. The only kind of regulations on the books are from the EFSA, which is the European version of the FDA. And they recommend that daily exposure levels do not exceed 7 milligrams per kilogram of body weight. But other than that, not really too much regulation on this. Now we have yellow 5. In terms of production, pretty much the same story. Now, it doesn't come from naphthalene. It actually comes from benzene, which is another organic molecule. But the benzene, of course, is derived again from coal tar. This hasn't been linked to any kind of hyperactivity or ADH symptoms, but it is reported to be the most reactive in terms of negative side effects of azo dyes. Apparently it is most problematic with people that have asthma or that are allergic to aspirin, because it's very similar in structure, or it breaks down very similarly to what aspirin does in your body. And in terms of FDA requirements, the FDA requires that it be on the label, and that it be certified as a yellow 5 dye. Other than that, not too much. Kind of use it as you choose. So now we're taking a look at this blue 1 dye. Now this is not an azo dye. So the red 40 and the yellow 5 are both azo dyes. They contain an azo group. The blue 1, on the other hand, is a triary methane dye, and again, it is derived from petroleum byproduct. It's actually made from benzene, the same as yellow 5, but a different process actually gives you this blue dye. It's used in foods, cosmetics, medications, and this one actually is interesting because its absorption is very poor in the digestive system, meaning that if you eat foods containing blue 1, that 95% of the dye is going to pass through your system without being digested, which, interesting side effect is if you do eat a lot of blue dye, you can notice that on the other end, if you know what I mean. Now we're going to take a look at the last ingredient, which is BHA. They tell us here helpfully that it preserves freshness, so we know that it is a preservative. The chemical name for that is butylated hydroxoanisole. It's an antioxidant agent, which means that it stops oxygen from binding with stuff. So if you think about like a piece of iron that's left outside in the elements and it rusts, that rust is an oxidation reaction. Now you don't typically want that to happen with food, because when foods oxidize, you usually get an off smell or an off flavor or both. Now actually in the case of tea is oxidized, but it's a controlled and purposeful oxidation reaction. Once this product's already made, though, we don't want it to oxidize anymore. So to prevent that, they put this BHA in here, and it does preserve the freshness. Now, interesting note, the U.S. National Institutes of Health do list this as a carcinogen. It's been proven to cause cancer in lab animals, specifically rats and hamsters. Now, I haven't done any controlled human studies, which is good, because we don't want them to go around purposefully causing people cancer. So that link hasn't been proven, but it has in lab animals. Now, as far as the FDA is concerned, they say that it is currently believed that the intake levels do not pose a serious health risk. So as far as the FDA is concerned, BHA is good to go as a preservative. But yeah, that pretty much sums it up. We covered the nutrition facts and all the ingredients for this Crystal Light drink mix. Now let's see if we can come up with a homemade DIY solution to actually replace this product. For this recipe, you will need 4 ingredients: instant tea, sucralose, stevia, and citric acid. It's important to note that for the sucralose and stevia, you will want to purchase products that measure cup for cup with sugar. Once you have the ingredients together, combine them all into a medium-sized mixing bowl. Now for an optional step, you will need a blender. Please note that if you choose not to do this step, you will need both a larger storage container and to add more flavoring powder to each of your beverages. Simply add all of the ingredients carefully to the blender and pulse until everything is blended thoroughly together and the volume has compressed. What we're doing here is breaking down the powder into its smallest and most compact form. Make sure you give the powder plenty of time to settle once you finish blending. And when opening the lid, be very careful as the powder is light and can easily mix with the air. Here's a shot that shows the difference that blending makes. The bowl on the left is the same amount of powder that has been unblended, whereas the bowl on the right just came from the blender. As you can see, it's much more compact and concentrated. As you can see, our homemade mix is very similar in texture and color to the commercial mix we saw at the beginning of the video. To store it, simply put it in any airtight container. I used an old mason jar. To test out my homemade mix, I decided to do a side-by-side comparison. Both glasses have the same amount of water in them. On the left, I dissolve 1 packet of Crystal Light Lemon Iced Tea drink mix. On the right, I dissolve about a tablespoon
of our homemade instant drink mix. This means that it does require a slightly larger volume of our homemade mix as opposed to the commercial brand. As you can see, they both dissolve pretty easily. Also, the color is very similar, and it's important to note that while the Crystal Light drink mix uses artificial food dyes, our homemade mix uses no dyes or artificial colors or preservatives. Here, take a look for yourself. And of course, this video wouldn't be complete without a taste test, so I gave it a try. And in fact, I was quite pleased with the result. I think you will be too. You can head over to my blog at nutribreakdown.com for the full recipe and links to purchase the ingredients. Let me know if you liked this video, or leave me a comment if you have a suggestion for a product you would like to see me break down. And remember to tune in next week for a brand new breakdown.